All right, example 10, this is where we're at. It says for each of the following angles, find the coterminal angles between 0 and 2 pi. Okay, so now we're in radian mode, right? There's no units here, so we assume if we're talking about an angle alpha, it's in rads, right? This is still within one positive rotation. Within one positive rotation. It's the same as 0 to 360, but this does two things for us. This tells us, number one, we want our angle to be within one positive rotation. But it also tells us, number two, that our final answer has to be in radians. Okay? So if you give me the equivalent angle in degrees, it's not going to be correct. All right? So it has to be in radians, and it has to be between 0 and 2 pi, which is once around. So I got 46,365 pi sevenths. Now, there's two options here. You can either convert it to degrees, do what we just did on the quiz, divide out 360, get the whole number, blah, 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 find the equivalent angle in degrees, and then convert it back to radians. That would be fine. But I don't want you to do it that way. I want you to start learning to think in terms of radians, and I want you to start learning to think in terms of fractions, okay? We're going to have a lot of fractions that are be coming around the bend. Okay, so let's think about this. One rotation is equal to 2 pi, yes, yes? Which is equivalent to what pi sevenths? That's my question to you. How many pi sevenths is 2 pi? 14, good. You have 2 pi's, you cut each pi into 7 pieces, you got 14 pieces of pi. That's just twice the denominator, right? 14 is just twice the denominator. 2 times the denominator. So here's how I want you to do these problems. I know that I have a certain number of pi sevenths, and I want to know how many full rotations that is. So I'm going to work with the coefficient. There's 46,365 of those pi sevenths. So I'm going to come over here and take 46,365. And I'm going to divide by not 360, but the number of pi sevenths in one rotation, which is what? 14. I'm going to divide by 14. That's twice the denominator. Let's see what we get. 4,6,365 divided by 14. This gives me the number of rotations. This is rotations. So just like we did when we had degrees, except we're dividing by a different number now, 14, because that's twice the denominator. What do I do with the whole number to make sure that I have the entire decimal stored? Do I just type in 0.785? Well, how do I do to get rid of the 3311? Subtract 3311. Right, not so? Yeah? Okay, good. And now I have, boom, look how more decimals appear. See that? We want to use the calculator's stored values. So we just get rid of the whole number by adding or subtracting, and we get this. And then I remultiply by guess what number? 14. So when you do it with radians, you're always going to be dividing by a different number. It's not always divided by 360. It will be always twice the denominator. You get rid of the whole numbers, and then you remultiply by the exact same number you divided by. Okay? So this then tells us that 46365 pi sevenths is coterminal with now 11 pi sevenths. That 11 is your new coefficient. It's your new coefficient of pi sevenths. Okay, it's your new coefficient of pi sevenths. So those two angles are coterminal with each other. If you do that, 11 pi sevenths is going to be within one rotation because 11 is between 0 and 14. Yes, yes? 14 pi sevenths is one rotation. Now, I want to figure out where it lives. So here's how we're going to figure out where it lives. This is 0, and this is also coterminal with 14 pi sevenths. 0 pi sevenths or 0 and 14 pi sevenths. Those are coterminal. What would the x-axis over here be at pi? What would pi be in terms of sevenths? 7 pi sevenths. Very good. What I need to do is I need to figure out what my quarter cycle counting interval is. So I'll do this. What's half of 7? 3.5. So this is 3.5 pi sevenths right here. Once you have the 90-degree equivalent in radians, you have your counting interval. That's how many pi sevenths it's going to take to get to your next x-axis. So let's just count by 3.5. From 0 to 3.5 is 3.5. From 3.5 to 7 is another 3.5. What's 7 plus 3.5? 10.5 pi sevenths. And then, of course, 10.5 plus another 3.5 is 14. Once you have your quadrantal angles labeled in terms of sevenths, now you can figure out where 11 pi sevenths must live. Where must 11 pi sevenths live? The fourth quadrant. It's a little bit past 10 pi or 10.5 pi sevenths. So this is 11 pi sevenths. Okay. Now, I want you to find the reference angle. If this is the angle theta, then the reference angle is the measure of rotation between where we land and the closest x-axis. So if I draw it, that should be right here. Yes, yes? Now look how easy this is. If that lands me at 11 pi sevenths, and the closest x-axis is 14 pi sevenths, how far is it from 11 to 14? 3 pi sevenths. And there's your reference angle. Ta-da! Ta-da! We got it. So 11 pi sevenths is your coterminal angle. I'll label that up here. That's your coterminal angle. And 3 pi sevenths is your reference angle. It's not only fun, it's easy. It's what? It's fun easy. And if it's not easy yet, it will be fun easy because you're going to practice, practice, practice. All right? That was the first one. We got one under our belt. You ready for some more? You got room under your belt for another one? I hope so. If not, loosen your belt. All right. We got negative 789,637 pi 11. So now we got a negative angle. No big deal. We're going to use the coefficient of pi 11ths. So I'm going to take negative 789,637. I'm going to keep the negative there. And now I'm going to divide it by what number? 22. This is twice the denominator. Twice the denominator. Why 22? How many pi 11ths in one rotation? 22. Yeah, 22 pi 11ths is 2 pi. So here we go. Negative 789,637 divided by 22. That's going to give me a negative number for sure. I want to get rid of the whole number amount. So I'm going to say plus whatever that number is. 35892. Boom. Notice more decimals appeared. Yeah, yeah? Okay. Once you get rid of the whole number, you're going to remultiply by the exact same number you divided by, which will not be 360. It'll be a different number every problem. In this case, it's what? 22. That gives you your new coefficient of pi 11. So here's what we could say. We could say theta is coterminal with negative 13 pi 11ths. The only problem is negative 13 pi 11ths is not between 0 and 2 pi, is it? It's a negative rotation away. So what did we do when we had a negative angle in degrees? We did one last step. We added what? One extra rotation to it, which was 360 when we're in degrees. But here I want to add one extra rotation, which is how many pi 11ths? No, it's the same number we divided by. 22. 22 pi 11ths is one rotation. All right? So all I got to do is now say plus 22, and I get what? Oh, is it 8.999999999, or is your calculator trying to say, hey, boss, I think it's what? It's 9. 9 pi 11ths. There we go. That's the answer that we want. That's theta coterminal between 0 and 2 pi. So again, you got that one extra step. If it's negative, you just add one more rotation to it, which you just add the same number that you divided and multiplied by. That's the star of the show. Twice the denominator, okay?
When you're adding one more rotation,
Yeah.
would you add 23? Because 22 is one full rotation, right?
No, one full rotation is 2 pi. 2 pi is 22 pi 11ths.
Okay.
You just add one rotation to it. You add 2 pi to it. Now, we're adding the coefficient in terms of pi 11ths, which is 22. It's always the exact same number that you divide and multiply by. Okay? Now we just need to figure out where it lives. So I come over here. This is 0. I know once around is 22 pi 11ths. Okay, what's pi? What's half of 22? 11 pi 11ths. That's easy to figure out, right? You need to figure out pi so that you can figure out this one up here because it's half of 11. What's half of 11? 5.5 pi 11ths. That is the most important number now for this partition because it gives you the quarter cycle counting interval, which gets you from one quadrantal axis to another. So I keep adding 5.5. What's 11 plus 5.5? 16.5 pi 11ths. And now I have all of my quadrantal angles labeled in terms of pi 11ths. So now it should not be a strain to figure out where 9 pi 11ths lives. Where's 9 pi 11ths going to live? It's past 5.5, but it's before 11. Yes, yes? So there's theta. All right. That's also theta coterminal. You can just call it theta because remember that's where theta lands as well, and we don't have to show those 35,000 rotations. Okay. Now I'm going to find the reference angle. The reference angle is this angle right here. Okay. So if this is 9 pi 11ths right here, that's where I get to that terminal ray, and the closest x-axis is 11 pi 11ths. What's the reference angle? 2 pi 11. See how much easier it is? It's actually easier because you're working with smaller numbers. From 9 to 11 is 2. Yeah.
So initially you started with a negative coterminal, right?
I did.
So with that, when you added the extra rotation, did that change the direction it came from?
No. In fact, let's look at that. Negative 13 pi 11ths would actually be that right there. That's negative 13 pi 11ths. It gets to the same terminal ray, but it does it by going clockwise instead of 9 pi 11ths, which gets there by going counterclockwise. They're both coterminal with each other. But why do I want 9 pi 11ths and not negative 13 pi 11ths? Because I read carefully right here, and it says I want it to be between 0 and 2 pi. I don't want a negative answer. So we add one more rotation to it. All right, let's see if we can squeeze one more dude in here. I got 1499873 pi. Notice there's no denominator. Can I put it over 1? Yeah. So let's take 1499873 and we'll divide it by twice the denominator. What's twice 1? 2. Okay, so 1499873 divided by 2. That's the number of full rotations. What do? Subtract. There might be more decimals that appear. 7499381. Nope, no more decimals appeared. So I just remultiply by what number? The same number I divided by. And I get 1. 1 is your new coefficient of pi firsts. So it's coterminal. So theta is coterminal with 1 pi oneths, which is known as what? Pi. Oh my gosh, where does pi live? Straight over here at 180. Okay, so that's the coterminal angle right here. Theta coterminal. This one does not land on the interior, does it? So what would the reference angle be? 0. But remember what I said yesterday? Is 0 an acute angle? No. So the reference angle is 0. There is none. There is no reference angle. It's collapsed down onto the x-axis. You can say D and E, right? That's fine. If your reference angle is ever 0 or 90, you say D and E because 0 and 90 are they're not acute. Okay, so if your angle ever terminates on one of the axes, there is no reference angle.
Is that how you draw the graph?
That's how you draw the graph. Yeah,
You don't no arrow.
I drew an arrow. Oh no, I mean if you want to draw this, you can. As long as the arc lands on the negative x-axis, we know we're good. Okay, keep practicing your homework. We're going to finish the notes easily tomorrow. Here's what I think I'll do, guys. On Monday, I think I'll just give you the whole class period to work on your worksheet in class. Okay? And I'll make it due by the end of the day at 4:20. So you don't have to try and struggle to get your worksheet done over the weekend. You'll have the entire class day on Monday to do it. That sounds like a good plan. All right. Okay.